Copper's exceptional electrical conductivity and heat resistance make it one of the most often utilized metals in the world. Applications for copper can be found in many different industries, including electronics, renewable energy technology, transportation, and construction. It is widely used in electrical wiring, plumbing, heating and cooling systems, architecture, industrial machinery, and much more. In today's Mighty Machines video, we'll be looking at copper mining and manufacturing from the largest deposits in the world. Sit back, relax, and get ready to learn. When it comes to copper mining, it's usually done through open pit mining. Mining on the surface that involves taking minerals out of an open pit in the ground is called open pit mining or open cast mining. Because it doesn't require tunnels or extractive techniques, open pit mining is the most widely utilized technique for mining minerals worldwide. The first step in mining copper is exploring the site of the open pit mining. Since copper is found in the Earth's crust, it can be extracted through blastings. These are planned and controlled explosions intended to fracture rocks containing copper. Drilling is done to create 16-meter-long holes that are then filled with a high explosive known as ANFO, diesel, and ammonium nitrate. Electronic devices are used to ignite the explosions in serial with a gap of around 2 milliseconds between each explosion. The material is placed into haul trucks, which have the capacity to carry up to 300 sports cars. After the explosion, these mines are operated from a control center atop a tower, which tracks movements in real time using GPS and sophisticated electronic communication networks. Depending on the grade of the copper, the material is carried to various sites. Low-grade material, known as dipetite, is deposited in regions set aside for this purpose and is considered waste. Leachables, also known as half-law materials, are placed on designated areas around the edges of the mine. On the verge of becoming Canada's third largest copper mine, the Copper Mountain Project is an open-pit copper-gold porphyry deposit. The project, which hasn't been developed in 15 years, will bring hundreds of millions of dollars to Princeton, British Columbia, and create over 1,000 direct or indirect jobs. Over 1.5 years and over 1 million hours of selfless labor went into the construction of the project, but now that the Copper Mountain Mine is operational and construction is finished, it was well worth it. The project is expected to yield about 105 million pounds of copper annually and uses a 5 billion pound copper deposit. The entire capital costs, with the assistance of a partner, Mitsubishi Materials Corporation, are $438 million. The mine is anticipated to continue producing for a very long period, with the support of a 75-25 debt-to-equity finance. Founded in 1976, the Chile Codelco is a state-owned copper mining enterprise situated in Chile. The company, which is among the top producers of copper worldwide, operates a number of mines in Chile, including the well-known El Teniente mine, which is regarded as one of the largest underground copper mines in the world. The use of enormous roto shovels at Chile Codelco's Division Radamaro Tamuc location is a noteworthy feature of the mining operations. These massive machines are used as continuous excavation tools in large-scale open-pit mining operations. Among the most important vehicles ever built, these shovels have the amazing ability to remove nearly 220,000 tons of leached material every day. Their distinctive design includes a large wheel and revolving pattern of buckets or baskets to collect materials. This innovative approach enables efficient and high-volume extraction of precious resources. At 3.8 million tons annually, Kamoa Copper Phase 1 concentrator is almost operating at steady-state design performance. By the end of 2023, the plant hopes to operate at steady-state design performance. Copper grades average between 2.5% and 3%, and recovery rates at the concentrator are steady. Raw ore is first crushed, pulverized, and combined with chemicals and water, and then fed through flotation circuits. A superior concentrate is created when the air bubbles are extracted to the copper minerals, before being sent to smelters for additional processing and refining. The concentrate is subjected to additional processing to ensure that it satisfies purity and quality criteria. For the non-ferrous metals sector, which includes copper, SMS Group, and a worldwide supplier of plant technology, along with processing machines and all-encompassing solutions for the value chain, they provide a variety of goods and services. The exceptional electrical, malleability, and thermal conductivity qualities of copper plants make them indispensable to the production process. Modern material handling, crushing, grinding, and separation technologies are all used in the copper plants owned by SMS Group. For maximum efficiency and reduced emissions, they also provide cutting-edge environmental control systems. They offer a full range of services, including renovations, plant modernization, and the provision of spare parts to prolong the life of current installations. The largest producer of copper and precious metals in North America is the foundry Horne, which has been in operation since 1927. They are a front-runner in the recycling of electronic equipment because they make 99.1% pure copper anodes using recyclable materials and copper concentrates. The smelter's capacity to adjust to changes in the worldwide market is demonstrated by their perseverance in processing complicated materials. They have security checkpoints to keep an eye on entrances and exits, an emergency squad, and specific infrastructure for training contractors and employees. The smelter recovers the sulfur and turns it into sulfuric steel. To meet global demand, it ships around 740,000 tons of copper concentrate and other metals every year. The company's significance in the copper business is demonstrated by its adaptability and capacity to handle challenging materials. SCC is a prominent global integrated copper producer operating in Mexico and Peru. The company has a wide range of products, including lead, carbon, zinc, copper, molybdenum, and silver. Since its founding in 1996, SCC has grown to become a major force in the world's metals market, listing its common shares on the Lima Stock Exchange in addition to the New York Stock Exchange. SCC has consistently shown a dedication to ethical mining methods by making sure that all of its operations follow stringent environmental regulations. This commitment to sustainability goes beyond the business's immediate operations and into the communities in which it operates, building enduring bonds with stakeholders and advancing regional advancement. A system comprising a melting and holding furnace and apparatus for manufacturing continuous cast copper wire rod is called a single furnace upcast line. Depending on the furnace size selected, these lines can produce up to 12,000 TPA, tons per annum. Compared to the traditional setups, they have many benefits, such as lower energy usage, fewer capital costs, simpler maintenance, and greater flexibility in terms of product mix and production numbers. The automotive, electronics, and construction industries are just a few of the areas in which single-furnace upcast lines find extensive and varied applications. These lines are perfect for small-scale producers since they can be readily scaled up or down in response to variations in demand. The 6, 8, 10, and 12 tons of molten copper storage capacity are the 4 possibilities. The factory run by the company In Order is the next on our list. This plant manufactures premium copper tubes to meet a variety of industrial needs, such as those in the plumbing, refrigeration, and air conditioning sectors. With a 100,000 metric ton annual production capability, the plant has the latest machinery and equipment and employs about 500 professional personnel. The HME Copper Tube Production Line is a cutting-edge facility that processes copper tubes effectively by using sophisticated technology and automated technologies. Selection of materials, preparation, extrusion, cutting, shape, polishing, and testing are all steps in the process. Premium copper strips are hand-selected and prepped for the extrusion process, which uses heat and hydraulic pressure to form the strips into hollow tubes. After that, the tubes are molded and tribbed to fit precise measurements and specifications. Following testing and polishing, the completed tubes go through stringent quality control inspections. After approval, the tubes are packed and shipped to clients all over the world. HME's dedication to maintaining product quality control is evident in this innovative production procedure. That's it for today's video, guys. If you want to learn more, we also have a video on 8 jaw-dropping machines from around the world. Go ahead and check that out. For more videos similar to this one, don't forget to like and subscribe.